So for Gaussian-Jordan elimination, now we're going to get into the 3x3s, which end up being a 7-step process. This is your goal. Your goal is to have a number here, a number here, a number here. If it looks like this, then it's really easy to see. X is this, Y is this, Z is this. And we did this before, but I'm going to show you the order again. You can get those zeros first, then you can get this 0 second. That's the same as Gaussian elimination. So we've done that part already. Gaussian-Jordan just needs the rest zeros and ones as well. So order-wise, after doing these, if you had 5 equals 20, do you see that it would be really easy to get this to be a 1 next? You could just divide that row by whatever number is there, and it changes it into a 1. Then once you have that as a 1, now you can use this third equation and work backwards and get both of those zeros. And so we sort of do Gaussian elimination backwards, where we need to get now the top corner is zeros. And once you get these zeros and there's a number here, this is going to be really easy to make a 1 next, followed by getting this 0, and finally this as a 1. That's our idea. And there's many different ways of going about it as far as how you write things. But to start off with, we need to make our augmented matrix. And sometimes when I make my augmented matrix, I really like having a 1 up there to start with. So you see in equation 3, I'm just going to write equation 3 first. -1, -2, -1, 1, -2, -1, 2. The other ones I'm not too concerned about, so I'll just write them in the order that they're there. 4, 1, 1, 5, 2, -1, 2, 10. So first, I want to get these two to be zeros. Draw a little arrow. So I want to change row 2, and I want that to be a 0. Can you see that if you took row 2 and subtracted 4 row 1s, that would make that a 0. Same thing, row 3. You can do these both at the same time. I can take row 3 and subtract 2 row 1s. It also would be perfectly fine if you would like to do it the other way. You'd like to do 4 row 1s minus row 2, or 2 row 1s minus row 3. It doesn't matter the order that you do that. And draw your matrix. Start with the one we didn't do anything to. I didn't change row 1, so I can rewrite it. Row 2 is row 2 minus 4 row 1s. That gives me a 0. Row 2. Is that good? Did I do mental math right? And then row 2 is 1 plus 4. That'll be 5. And 5 minus 8, -3. Next, row 3. Minus 2 row 1. That'll get me my 0. This is what I wanted to do first. Get those 2 zeros. -1 plus 4, 3. 2, row 3, 2 plus 2, 4. And 10 minus 4, 6. Okay? This is what I wanted to get first. Done. Next, I want to get this to be a 0. In this second step, we're going to want to change row 3 to get that second 0 a 0. Can you see in this step that you are only allowed to use row 3 and row 2? This is important. Why can't I use row 1? Because if I do any math with row 1, what's going to happen to the 0 in the bottom left-hand corner? Yes, left. Good. That 0 in the bottom left-hand corner is not going to be a 0 anymore. So I'm going to have to use row 3. I'm going to change row 3. I want to get that 0 here. And I have to use row 2. Any ideas? How do you like this? If I take row 2 and I minus 3 row 3s, 9 minus 3 of these, that would give me 0, right? Okay, let's see how that works out. 1, negative 2, negative 1, and 2, and 0, 9, and 5, and negative 3. Those two rows aren't changing, so we can just rewrite them. And row 3 is now row 2 minus 3 row 3s. Look first of all, this first one. You'd have 0 minus 3 times 0. This stays a 0. Very important. But now I'm going to have 9 minus 9, 0 there. 5 minus 12, negative 7. And negative 3 minus 18, negative 21. Step 2, we got all our zeros. Next, it's really easy to make that a 1. If I just take row 3 and divide it by negative 7, I'll get a 1 there. So this is kind of a boring step because we're just spending a lot of time rewriting things. Rewrite that one, rewrite this one. And now 0, 0, 1, if I divide by negative 7, I know that it's 3. In Gaussian elimination, you can now just plug in things and work your way back, and you would be done. Now we sort of do the reverse process up. Next, we want those two to be zeros. Oops. And when you're making them zeros, do you see that it's going to be really nice to use row 3? So not only do I want to make these zeros, I want to make them zeros using row 3 because my row 3 is just a 1. A lot less mental math to do. So to make the 0 in row 1, can you see that you could just do row 1 plus row 3? And to make the 0 in row 2, I could just take row 2 and minus 5 row 3s. And again, it's not wrong if you would have done, well, not wrong, but you can make it harder. You could take row 3 and minus 1/5 of row 2. You see how that would make your life a little bit harder if you went to fractions? So, but it's not wrong. You have tons of different options. So again, I'm not changing row 3, so I can rewrite it. 0, 1, 0, 0, 1, and 3. Row 1 is going to be row 1 plus row 3. This is really easy because row 1 was 1 plus 0, negative 2 plus 0, Negative 1 plus 1, perfect, I got that 0. And then 3 plus 2, that'll be 5. And row 2 is going to be row 2 minus 5 row 3. So 0 minus 0 will be 0. 9 minus 0, this will still be 9. 5 minus 5, that'll be 0. And negative 3 minus 15, negative 3 minus 15, negative 18. I now succeeded in getting these two as zeros. Next, it's going to be really easy to get the middle 9 to be a 1. You can just take row 2 and divide it by 9. That would change it to a 1. Now we know that y needs to be negative 2. Next, we need to make this a 0. The negative 2, we need to make that a 0. We're going to need to change row 1. I could do row 1 plus 2 row 2's. Do you see that you have to use row 2 here? It's the only way that nothing in row 3 will help us. So rows 2 and 3 aren't changing. If I take row 1 plus 2 row 2, this will still be a 1. This will be negative 2 plus 2 be 0. Be 0 plus 0 will be 0. And 5 plus negative 4, x equals 1, y equals negative 2, z equals 3. If this was non-calculator on a test, you could now go back to these original equations. X equals 1, 4, plus a negative 2, 2, plus 3, 5. Equation 1 works. Equation 2, 2 times 1 would be 2, minus a negative 2 would be 2 plus 2 is 4, plus 6, 10. Second equation works. Whew. I'm feeling more relaxed at this moment because it's working. Right? I'm not getting into that matrix frustration where you did something wrong and your probably best choice is to start all over again. And 2 plus 4 would be 6. Oh, what did I? No, it's 1. Okay, x was 1. 1 plus 4 is 5, minus 3 is 2. Whew. All three equations work. If you have a calculator, you could type your augmented matrix into your calculator and use the reduced row echelon form part to see what the right answer would be. You are like, I did 2 steps here, okay? What's hard about doing the next step here is that you're going to need to use row 2 after it was simplified here. So probably the most you can do, and I would recommend this, is only in this step where you got those as zeros. I did 2 at once. And I did 2 at once when I was getting those zeros. Everything else, basically you have to do 1 at a time, because in order to get this 0, it's sure helpful that this was already a 1. Yes, you could have got this as 0 from here by doing 9 row 1s plus 2 row 2s. But then your numbers are going to be a lot bigger to work with, so this would be recommended. And that being said, sometimes you think you're doing something the most efficient way, and you get very big numbers, just depending on what you're working with. And how, like, A small little thing that I did here to make my life easier was start with the 1 in the top left-hand corner, right? I wrote this. It's not wrong if you wrote it exactly as the equations were written, but you will get different numbers as you're going through. In the end, you'll get the same answers. So just depending on how you choose to cancel things, how you've chosen to write them down, may make your math look different than somebody else's, but it should result in the same thing. If you need loose leaf, well, you might have enough space on there. Here's one for you to try. You want me to go back?
No, can I go to the bathroom?
Oh, yes, you can go to the bathroom.